Well, welcome to the second edition on the Comprehensive Machine Learning Watch List Guide, recommendation of the ASOMAI YouTube channel. We put this together in order to ease our affairs and to make it beneficial for the participants and those that might also find it online. So because we've had, to God be the glory, so over 137 videos, as mentioned last week, has been uploaded. So getting to the channel and being able to navigate where should I start? I actually got a couple of questions on this. That one of the reasons that necessitated this effort, that, okay, can we provide a guide? So if you are just joining, there are places you can just check, and then you can benefit yourself by looking at what to do at the beginning and how you can then progress gradually until to the professional level. So last week, we were able to start this out of 9 subsections. I think we were able to reach number 4. So we started with the live revision section, which is the very most important for new members. So by the time you are done with these few videos, at least you have an idea of what machine learning is, and then what is required, the different types of machine learning. We discussed this extensively last week. Then we moved to playlist 2, which is how can you practicalize the basic principles of machine learning you have covered in weaker environment. So weaker has been chosen as it is very easier for anybody to easily deploy application, build model using weaker. So I'm aware of the fact that people are from different backgrounds. So that's why we decided to be using Weka for now. And the principle of our weekly program is machine learning for all. I want to believe that everybody, irrespective of your background, you can benefit from the power and the capabilities that AI and various fields of AI are actually providing. So once you are done with that, we also have under that what we call the Hello World machine learning, where very basic predictive models have been built using Weka. So once we are done with that, we move further to the third playlist. We discuss about the tour of selected classifiers. So that sometimes it's also good for you if you want to know some details about the working principle of those classifier or algorithm that are being used to build the model. We started with sample 1, very simple, k-nearest neighbor. We had decision tree, naive Bayes, which is probabilistic based. And then we moved to support vector machine, of course, which is one of the very popular, very powerful, and highly efficient, accurate algorithm among the list. So we have several sessions on support vector machine due to its special nature. And then we move to what we call the Researcher's Corner playlist. This is where for those people who are interested in using machine learning to carry out research, to run modeling in their own various areas of specialization. So this is a playlist that is dedicated to such. So for those who are not interested in research, so this is the essence of it. You don't need to bother yourself about that. Then those who are interested will know that, oh, let me go to Researcher's Corner, and then I can be able to check out some of these videos, see, starting with how do you write abstract when it has to do with machine learning based research. So how do you write the abstract? How do you write the introduction? Also, a special template has been provided in this respect, whereby you can, this video describes the template from beginning to the end. So you can have a look at it and then be able to see, okay, the templates will probably be made available in our forum. So a few updates are being made to it. As soon as it is done, we'll make it available, definitely, inshallah. So also we provided some guides on how do you make research collaboration, so especially machine learning based research, and there are a lot of questions and answers in that respect. So how do we identify the gap? Gap identification is another very important thing when it comes to carrying out research using machine learning. So the fact that someone already work in a particular topic doesn't mean you cannot work there. You just need to understand how can you create a gap? How can you detect the existing gap that you can fill? As we know, when you are doing research, there must be something unique that you want to bring on the table. So we discuss in this video, how do we identify gaps in research? So, and it's very, very important and also very useful. So then we also, under the researcher's corner, how do we carry out your machine learning experiment for your research in a weaker environment? We have a couple of videos on that. Yeah, I think that was where we stopped. That was what we had last week. So this week we're going to take number 5 to 9. So hopefully, so finishing the presentation of the guides on the YouTube channel. So this is real life applications of machine learning. So first of all, we started with having brief summaries of past successful applications. So this is, again, I always tell people that no matter where you're working, you can always get machine learning to support you. But you need to have a kind of a view and have an understanding of how can I do it? Is it possible? So in order to motivate our members, we had several videos in this series. We were discussing real life applications of machine learning. What are the possibilities? So you can see part 1, part 2, part 3. Several issues were actually discussed. And sometimes we mention even proof of concept. It's not just theoretical, but some of the real life applications that have been built by our team and they are operational were used as proof of concept to really demonstrate that, yes, you can actually use or deploy machine learning in your various areas of specialization. Then, yeah, and also it's in series, part 1, part 2, you see them discussing various applications of machine learning in real life application. Yeah. In this one also, we'll come back to something similar to this later. This is where specifically we were looking at some specific published work, which is going to support, especially people that might be interested in the research aspect of the work, and also even real life applications. So the next playlist to look out for is what we call machine learning, digging deeper playlist. That is, here we describe the ensemble techniques. So ensemble techniques is one of the ways of making sure that sometimes individual algorithm might not scale up to the problem you are trying to model, because based on the principle of let the data speak. Let the data speak. So you have to use, there's no algorithm that can always work for you. So you have to check, use this one, use another one, see the one that is able to detect what the data is trying to communicate. Sometimes the most powerful algorithm might not be able to detect it. A very simple one might detect it. This is one of the principles of machine learning is you have to start from simple algorithm, then gradually you make it to more complicated algorithms. Because complicated algorithm does not indicate that it's going to work for you. So start simple until to more sophisticated ones. But sometimes, no matter what you do, individual models might not be able to scale to the maximum that you need. In that case, you might need to go forward to what I call ensemble learning. Ensemble learning, we had several videos also, there's several weekly sessions on this. So we can see here part 1, part 2, part 3, part 4, part 5, describing different kinds of ensemble. Ensemble can be kind of compared to what we call a kind of togetherness. We can do things better than what an individual will achieve. So we have different algorithms, run them individually, then merge them together to come and jointly take decision on what you want to estimate or the prediction you want to make. From experience, you're going to see that under the justification for ensemble, by the time you watch part 1, part 2, you see some of the real life application in the world. that there are a lot of competitions. It has been reported that ensemble techniques are always the one that are winning the game, because if the data set is very complicated, it might not be possible for an individual model to be able to scale through and understand the intricacies in those data sets. So in that case, you have to go ensemble. So throw in many algorithms, like 151 different algorithms. And then you come and merge them together in an ensemble techniques. It could be bagging, it could be boosting, it could be stacking, actually. There are different types of ensemble. So watching through those videos will be able to provide you with the needed guide. What is ensemble? How does ensemble work? And then what are the different types? So commonest among them is the bagging, the boosting, and one of the recent one is called the stacking ensemble. So, and as you check out some of these videos, you have any issue, any question, feel free to document it. So this is opportunity for you in our live sections on weekly basis. You can be asking some of these questions, and we are always ready to provide the clarification as the case may be. That is an ensemble. And then we move to another playlist. Another playlist is a topical machine learning concept and issues. Before we move to that, I would like to clarify on this one that for the ensemble, so we don't need to jump to it immediately. So, since this is a powerful one, I will always go for it. No, start simple one. Because what you gain in ensemble, you lose some things. And that is the explainability of what you have done. Ensemble makes your model to become more of black boxes, because a lot of things are going to be mixed together, to the extent that you might not be able to explain to your client what has really taken place in the background. Yeah. So, however, a very simple algorithm like decision tree, you can easily explain to your client what you have done. Even yourself, you can easily understand what is going on. So the system is only making it faster. So that's why we always recommend start from simple algorithm, k-nearest neighbor, decision tree, naive Bayes. And then if things doesn't work out for you, then you can progress to support vector machine, neural network. And in the worst scenarios, things are really very tough. For example, in most competition, they don't give ordinary data in competition. They want to give, because like in competition, I saying, okay, if you are able to improve our predictive solution by 10%, we'll give you $1 million. So $1 million is not a joke. No one will give you $1 million for a task that you can just do within a few minutes. No, they know that they deliberately go for data sets that are very, very hard to crack. In that case, you still start with simple algorithms, then try to build several ensembles, several base learners, and then bring them together as one big family, and then they can jointly take decision. And this has always worked out, that very tough data set will finally be demystified using appropriate assembling techniques. However, it's complicated to build, takes a lot of time, and also you lose the explanations of system. Sometimes the clarity might not be very obvious to people, but sometimes you don't have option, you have to go to that level. But the message is, this is not the starting point for you. You must have tried simple algorithms and more sophisticated algorithms, and then it seems there's no one of them can actually get you what you want. Then in that case, you might graduate. Usually we say this is one of the last steps for you to try. So check out those videos. You see also the different types of ensemble you can have. And now we have topical machine learning concepts playlist. So here, this is where we be adding some very unique concept about machine learning. And they are, for example, bias variance trade-off. Bias variance trade-off. So it's a very common problem in machine learning, whereby when you are trying to train your data, if you train it in a simple way, in a lazy way, it could lead to underfitting. Underfitting means it's not going to be able to model the system. You see? However, as you are now trying to avoid overfitting, You now train it too much again, then it goes to overfitting. You see, you don't want to be underfitting, it goes to overfitting. So bias is the opposite, variance is the other side. They are both on the opposite side. As you are trying to reduce bias, you are increasing variance. So you have to have a trade-off that, okay, this is where I'm going to stop. You don't want underfitting, but at the same time, if you want to you want it to understand everything perfectly, then you move to overfitting. That is why you have a trade-off. Bias variance trade-off is a video that we demonstrated and explained this concept, which is very, very important and very popular in machine learning parlance and applications. So we also discussed here how to implement different partition method for model building in Weka. So here, practically demonstrated how do you implement data partitioning. This is when it comes to you, how do you evaluate your model? Which kind of partitioning method are you going to use? Are you going to use the holdout method where you divide your data into 70, 8, 30%, or 80%, 20%, depending on the ratio? Or you are going to use the n-fold cross-validation. So these are presented here and demonstrated. So for us. Also, among the concepts that's being added to it also is what we call machine learning is a tool, not a dogma. Machine learning is a tool, not a dogma. There's this misconception that, okay, there's a particular machine learning that you can use it, it's only going to get you good results. No. Any tool can fail. A dogma is something that is known to be true in all situations. It doesn't change. That is not machine learning. You might build a machine learning algorithm or model using a particular algorithm. Like support vector machine is very powerful algorithm that are always, most cases, it has always displayed exceptional ability. However, we've had cases that it was performing miserably in a particular application. And even k-nearest neighbor was performing better than it. This is the idea of machine learning is a tool, not a dogma. A tool can fail at any point in time, so you have to always try and check out other possibilities. So this concept was explained in detail. Machine learning is a tool, not a dogma. You have the video and the question and answer section. Also, here under the principles and important concept of machine learning, we have what we call course of dimensionality. Course of dimensionality. So it's a very important concept in machine learning. It's well explained here in this video. It's practically saying that the number of features you have, if you want more features, because more features or attributes indicate more information, but then unfortunately, the more if your feature is more, then you need number of samples to be more. So let's say you have like 15 attributes or features, then you are expected to have in the range of maybe 15 raised to power 10 samples. But in most cases, we all know that samples are limited in number. See, your client only sent you maybe 300 samples with 15 features. That is grossly inadequate. So this is where the cost of dimensionality arises. It says that as you increase the number of features, the number of samples needed will increase exponentially. This is the concept, exponentially. And you know, exponential increment is the one that is the worst in terms of algorithmic analysis. So no system can meet up with it. So if you have one feature, you are expected to have like 10 raised to the power 1 samples. You have 2 features, you are expected to have 10 raised to the power 2 samples. If you have 3 features, you are supposed to have 10 raised to the power 3. Just imagine from 10 to 100 to 1,000, 4 features mean 10 raised to the power 4. So where are you going to get 10,000 samples? So as the number of features increases, then the expected number of samples to make the system work also increases. So this is called cost of dimensionality. You see, a problem that comes with higher dimensional system. Again, support vector machine, that's why it's unique. If you notice, we spend a lot of time on it. It has a unique capability to avoid cost of dimensionality problem. That's why a lot of people always try it on their problem, and in several cases, it do work out. However, don't forget, machine learning is a tool, it's not a dogma. It doesn't mean it's going to work for you in all situations. No, that will break the principle of let the data speak. So that is cost of dimensionality. It's well explained here. You can check it out. So also step to building machine learning models. So we value this based on feedback and mistakes we notice that our students and our members actually are making. We went into this kind of a system whereby we look at what are the steps to be taken while we are building machine learning system. So we have here the principle of always let the data speak. Always let the data speak. So we have several videos in this series. So how do you, the way you upload your data, what are the necessary to do, the different partitioning approach also you want to use, they are all described here, still under the concept and principle. Here, this video specifically explain the concept of underfitting and overfitting. The first one was bias and variance. How you know bias and variance in a layman voice is to look at the underfitting and overfitting. Underfitting means your model, when you finish your modeling, both your training set and testing set performance will be very poor. It means the system is not able to understand the data. However, in overfitting, your training set could be 100% performance in the training set. But when you introduce unseen samples, it goes down 20%, 15%, or it doesn't even work. It does even lesser than that. So in this case, we call it overfitting. It means your model only memorized the data. It memorized the training set, but it's not able to extrapolate to new unseen samples. So this concept was well explained here. And a lot of people also do make mistake. Sometimes when you have like 80% performance in your training set and 75% in testing set, some people say this is overfitting. No, this is not overfitting. You see, before you can say overfitting, your training set must be too high, 99, 98, 100%, or 97. However, your testing set is abysmally poor. This is how you note it. So the explanation was really well presented in this video. So we can also check it out. So we also have another concept. We say taking benefit of machine learning modeling irrespective of your background. Yeah, so it's going to be a very nice also video for people to check out. So irrespective of your background, where you are, medical, doctor, environmental, just name it. You definitely find a way that machine learning can fit into what you are doing in your daily, day-to-day activity and your hobbies. And then the 8th playlist, that's what we call discussing published machine learning based papers with demo. See, so we selected a couple of published work, which we can call proof of concept, and we also demonstrated how this has been carried out. So among the papers that we described was what we call predicting anxiety during COVID-19 pandemic. It was a paper that was published during the COVID-19 period. So on how anxiety could be preemptively diagnosed so that people could be provided with support. So you can check out the videos, some videos in that series up to almost part 4. We also look into preemptive diagnosis of Alzheimer's disease. So also we demonstrated how it was done. This is preemptive diagnosis of Alzheimer's disease. Preemptive means before the disease actually shows symptoms. Usually the symptoms are already in the body, but it takes time for you to show. So the idea is to diagnose diseases before the disease actually starts showing symptoms, because often than not, by the time the symptoms start appearing, then the disease is already getting to late stage. So while people are still working, going about their activity, not living a normal life, can we diagnose them to know if they have any issue so that they could actually start treatment. Sometimes even life changes, life pattern changes or habits can even resolve the issue if detected at a very early stage. So this is the idea of that preemptive diagnosis. It was presented in maybe I think part 1 and part 2 or so. So we also had that was still part, okay, up to part 3, you can check out that. We also have another paper which we demonstrated and discussed how it was done in novel ensemble-based techniques for the preemptive diagnosis of rheumatoid arthritis. So this diagnosis was done using ordinary clinical data, no imaging, because often people use imaging, but simple clinical data can actually help people diagnose. And this rheumatoid used to be categorized as one of the very tough disease to diagnose by medical teams. So, and the recommendation was provided for by a very senior medical doctor that people face challenge in diagnosing it. And that work was able to use ensemble techniques. You can see individual models were not able to model it properly. So ensemble techniques was demonstrated. So you can check out the video on that, demonstrating how that particular disease has been diagnosed using clinical data set. And then it was in series, we have them there. So, yeah, and finally, but not the least, we also have few special invited seminar presentation series videos. So there are some invitation we had where I had to present work on the machine learning for improved health care delivery, taking clue from the past successful application while exploring the present and future. It was presented in 2022 at the College of Public Health and Imam Abdurrahman Faisal University. We also have another edition also. This, you can see the video there. We also have another edition also in 2023, and also a couple of other invited presentations. So we put them there in case it might also be beneficial to our viewers. So I believe this is actually some of the compilation for now. And sorry, last but not the least, once again, we have the compilation of our summer school videos. In 2022, we held our first summer school. So, and the videos were compiled. It's a lot of videos, especially for people who are new, because it was the 3 days program that was meant to summarize what machine learning is and also demonstrated how to build model in weaker. So for those who are really maybe not much time is available, these videos, they are very compressed because within 3 days, we finished the entire program, and anybody who attended it can also be able to start modeling using machine learning in their field. It's made of several videos, 2 sections per day, and for 2.5 days or 3 days, as the case may be. So we also provide the video in this guide. So hoping that all these compilations will make our journey towards being able to take benefit of this interesting field and the field that is trying to change the way things are being done in the present world order. So this is what we have in the ASOM AI machine learning video watch list guide and recommendation. And the good news is we are going to continuously update this file, and we are going to be posting it in our WhatsApp group and the Telegram group. So make sure you always look out there and follow it, and then take whatever you think you are in need of at the present. I know you cannot watch everything at a go. This is the essence of the guide. You can look at what you think is going to benefit you now, and then pick it up, note down whatever question you have, and then next edition of our meeting, you can always ask questions in order to seek clarification. You can go. Thank you very much once again for listening. I wish you all the best.